Why is it spicy?
Okay.
Why don't we eject our trash into the sun?
I love this question. Let's do some calculations. So ideally, at this point, we would use like a Falcon Heavy because that's going to be the cheapest alternative, but let's go middle of the line right now and say we're going to use an Ariane 5 rocket. First point, Ariane 5 rockets are about $200 million per launch. Second, an Ariane 5 rocket can get like 15,000 to 16,000 pounds of trash to space. But it's estimated that humans produce 2.6 trillion pounds of trash per year. So by that math, it would take about 168 million Ariane 5 rockets at $200 million per launch. Okay, but scrub that. Let's say we're using the Falcon Heavy and it's like half the cost. It would still cost you $15 quadrillion per year. That's 82,000 Jeff Bezoses. Sorry, it's too expensive.
See if it actually works. Whoa!
Raga, troppo bello questo video, infatti adesso scopriremo se è vero oppure fake. Il materiale ce l'ho, ma prima ricordatevi di seguirmi e di mettere mi piace a questo video e se vi va di taggarmi se volete che provi un altro video come questo. Per iniziare verso un pochino d'acqua in un piatto così. Poi prendo una penna e le taglio via la punta così. A questo punto devo soffiare per far uscire un pochino di inchiostro. E infine prendo l'inchiostro e lo immergo nel piattino. Bellissimo!
Si ves esto azul, tenés daltonismo. Si ves esto rojo, tenés la vista normal. Y si ves esto amarillo, sos una zorra.
Ça, c'est clairement une des matières les plus bizarres.
Elle est liquide quand on la manipule tranquillement. Hein, voilà, elle s'écoule, je peux enfoncer ma main. Ok, je peux en récupérer, c'est vraiment liquide, ça coule.
Mais elle est solide quand on la frappe ou qu'on vient la manipuler avec force. J'arrive pas à m'enfoncer, c'est trop bizarre. Aïe, non mais sérieusement, c'est fou. Donc là, tant que je le manipule et que je lui impose des forces, il est un peu solide. Je peux le casser net. Si je le lâche, il est liquide. Je vous jure, il n'y a rien de plus bizarre que cette matière. Le mieux, c'est que vous pouvez la refaire très facilement chez vous pour expérimenter ce truc. Faut juste mélanger de la fécule de maïs, de la maïzena en gros, avec de l'eau. 2 verres de fécule de maïs pour 1 verre d'eau. Et si jamais c'est trop liquide, vous rajoutez un petit peu de maïzena. Le truc qui rend ce fluide étonnant, c'est que sa déformation n'est pas directement proportionnelle à la force qu'on lui applique. C'est pour ça que ça s'appelle un fluide non newtonien. Ma main rentre tranquillement dedans si je l'insère lentement, c'est liquide, c'est bizarre. Mais si je mets des grosses patates, ça durcit instantanément. Refaites cette expérience chez vous maintenant.
How effective is a cigarette filter? I decided to make a lung, or something that represents a lung. In a closed system, I put some cotton wool. The cotton wool represents your lung cells. And this is what the cotton wool looks like after the smoke has passed through a single filtered cigarette. The footage you are about to see is of 2 types of cotton wool. The first sample of cotton wool hasn't had any smoke pass through it as shown here. Nice and clean, right? And this is cotton wool after a single cigarette has been smoked. This is representative of your lungs after smoking a single filtered cigarette. A 2011 comparative study by Hidemi et al. Concluded that filtered cigarettes only alter the type of cancer you risk getting. Filtered or unfiltered, the message is clear. Smoking is really dangerous for your health. So make the change today. You got this.
What is the big blue wheel at CERN?
What is the big blue wheel here at CERN? Well, first, here's an incomplete list of things it's not. A Stargate portal to hell, a fan to keep King Kong cool during the summer, an electronic blueberry and cantaloupe pizza. This big blue wheel is one of 2 wheels that are brand new detector components being added to the Atlas experiment at the Large Hadron Collider at CERN. And that's a mouthful, so allow me to explain. The Large Hadron Collider is a 27-kilometer circular tunnel on the border of France and Switzerland, about 100 meters underground. And in this tunnel, we use superconducting magnets colder than outer space to accelerate protons, you're all made of protons, to 99.999999% of the speed of light in two opposite directions. And then at 4 points on the ring, we slam the protons together millions of times a second, briefly recreating the conditions of the universe as they were just a fraction of a second after the moment of the Big Bang 13.8 billion years ago. Side note, no, we're not actually making a new Big Bang at the Large Hadron Collider, just like when you install a saltwater aquarium in your home, you're not actually making a new ocean.
Neither are we branching off multiple universes or anything like that. That's its own video.
But record scratch, why would we want to do this? We have a large number of big open questions in physics, and to answer them, we need to learn more about what was happening just after the moment of the Big Bang, which is currently a mystery. And you can't do this by slamming together two baseballs. You need a more sophisticated experiment like the Large Hadron Collider and its very high energy proton collisions.
And the places where we slam these protons together, we better build a gigantic detector, because quantum field theory magic, side note, not actually magic, is going to happen. Atlas, my current experiment, is one of the 4 main detectors on the Large Hadron Collider ring. And Atlas is 6 stories high, 46 meters long. It's like a big soda can tipped on its side and filled with complicated electronics and buried 100 meters under the ground.
Well, that ended abruptly and didn't explain everything? Oh, I see. Parts 2 and 3 are coming soon.